Welcome to the Pro Tips video series designed to arm biology learners with background knowledge needed to kick butt during upcoming lessons. Students are encouraged to watch these tutorials before attending lecture on the topic and rewatch them while studying. I'm Professor Workman, and today's Pro Tips are about dosage calculations. There are generally two steps to any dosage calculation problem. These steps can be completed in any order, and the math will result in the same answer. These steps include converting to the correct metric unit in order to match the prescription and adjusting the dose for the patient's body size. For example, consider a veterinary clinic that treats Great Danes and Chihuahuas. These dogs need very different amounts of medicine due to the big difference in their sizes. It would be unsafe and potentially lethal to give a Chihuahua a dose that is appropriate for the Great Dane. Similarly, pediatricians and parents carefully calculate child-sized doses that contain less medicine than an adult body would need. Consider this example from a vet clinic. Two siblings visit the clinic, and laboratory testing reveals that they both have the same bacterial infection. How much antibiotic should each pet be prescribed? For the sake of this example, we're going to use this real-life veterinary prescription called Zenequin, which is an antibiotic that's used to treat both cats and dogs. And here is the dosage for cats and dogs based on their weight in kilograms. However, Kyle, the cat, and Booker, the dog, have weights that have been recorded in pounds. Pounds is not a metric unit, so what should we do? Here's the information we know. Next, let's apply our two steps. We also need to look up the conversion factor from pounds to kilograms, because notice that the prescription for Zenequin is given in metric units, and this is true to life because remember, all scientists use the metric system of measurement, including medical and veterinary scientists. To solve this problem, I'm going to consider the dosages for Kyle and Booker separately. Let's start with Kyle. Kyle is 9.9 pounds, but in order to calculate the Zenequin dose, I need to be able to describe his weight in kilograms instead of pounds. To figure this out, we need to make a conversion factor. A conversion factor is helpful because we will design it to equal the number 1. Such that when you multiply by it, the value of Kyle's weight does not change. We design the conversion factor to equal 1 by making sure that the amount described on the top of the fraction is the same as the amount on the bottom of the fraction. 1 kilogram and 2.2 pounds is the same weight. It's just described with different units. Remember from math class that whenever the top and bottom of a fraction are the same, that fraction equals 1. Also remember that if you multiply anything by 1, it just equals itself. So 9.9 pounds times 1 is going to equal the same weight. 5 times 1 equals 5. 10 times 1 equals 10. Z times 1 equals Z. All right, so here's Kyle's weight multiplied by the conversion factor that will allow us to convert kilograms into pounds. This works because in order to multiply, we multiply across. So this becomes one big fraction, 9.9 pounds times 1 kilogram on top, divided by 2.2 pounds on the bottom. Remember from math class that if something occurs on both the top and the bottom of the fraction, it cancels itself out. In this way, the units for pounds cancel out, and I don't see anything else in this big fraction that cancels out. So this big fraction has been cleaned up. We've removed the pounds that canceled, and now we just multiply those numbers across. So 9.9 times 1 kilograms divided by 2.2 is 4.5 kilograms. So Kyle weighs 4.5 kilograms. Now that we have Kyle's weight described in the correct metric units to match the prescription dosage for Zenequin, let's adjust for his body size. He weighs 4.5 kilograms. That's his body size. Zenekin is prescribed at 2.75 milligrams per kilogram weight for a dog or a cat. So now we get to practice again with multiplying these things across. 4.5 kilograms times 2.75 milligrams is all on the top of this big fraction, and 1 kilogram is all at the bottom. But what do you notice? Can we cancel anything? We sure can. Kilograms occurs on both the top and bottom of this big fraction, so it cancels out, leaving us with the only units left being milligrams. Now I use a calculator to calculate the final answer, and it has several decimal points, so I'm going to round it. Kyle should take about 12.4 milligrams of Zenekin per day to treat his bacterial infection. Next, let's apply the same logic to calculate Booker's dose. He weighs 66.1 pounds. Booker's a chonker. We will multiply his weight by a conversion factor in order to describe his weight in kilograms instead of pounds. This conversion factor works because the value on top of the fraction is the same value as on the bottom of the fraction. Thus, this fraction equals 1. And when we multiply it through, the pound units will cancel. Here you can visualize the great big fraction that's made when we multiply across, and notice that since pounds occurs on both the top and the bottom of this fraction, it cancels out. Here's the big fraction with those pounds removed because they got canceled out. And I use a calculator to calculate this through. 66.1 times 1 kilogram, well, that's 66.1 kilograms divided by 2.2, or 30 kilograms. So Booker weighs 30 kilograms. Now I'm going to adjust the dose of Zenekin to match Booker's large body size. So I take his weight, 30 kilograms, and I multiply it by the dosage of Zenekin. For dogs and cats, remember that 2.75 milligrams per kilogram body weight is prescribed per day. So I multiply this through, and Booker's correct dose is 82.5 milligrams of Zenekin per day. So now if you're the veterinarian, you've calculated that Kyle should take 12.4 milligrams of Zenekin per day, while Booker should take 82.5 milligrams per day. These are very different doses because these animals are very different in size. For more practice solving dosage calculation problems like these, see the PDF attached in the description box, which contains practice problems and also explanations of their solutions. As a reminder, you learned that dosages depend on body size and that you can convert between different units by multiplying by conversion factors designed to equal the number 1. Because if you multiply by 1 any number of times, you're not changing the value. You're just adjusting the units that you're describing that value with. Thanks for watching. If you liked this video, you might consider watching other videos in the series. Here's my contact information, and I always welcome any feedback. mworkman@pima.edu. Good luck in your biology journey.